Humbert here. Today we're going to be doing Unit 5, Notes 2. So I'm going to go over the first part of graphing quadratics. So this is partially what you prepared for on the previous note sheet when you talked about the parts of the parabola. So we talked about this magical word parabola. So now we're going to actually go through the work of graphing said parabola. So let's go ahead and let's take a look at this in practice. So taking a look, you did this yesterday. You calculated your A, B, and your C. So for this one, your A is -1, your B is 6, and your C is 4. So in order to determine if it opens up or down, you need to look at the A. Well, the A is negative, so that means it's going to open down. Now I'm just going to point something out to you here that you're going to need later on. If the parabola opens up, that means the vertex is a minimum. Okay. If the parabola opens down, that means that the vertex is a maximum. So we're going to be kind of using that as we go forward on graphing our parabolas here. And you guys did draw that out on your parts of the parabola on that minimum and maximum. So just kind of keep that in the back of your mind here. So in order to calculate out the axis of symmetry, remember the formula that you use is opposite of B over 2A. Okay, so -6, and that's going to be a -2. Well, -6 divided by -2 is a +3. So the axis of symmetry is that x is equal to a +3. So now I need to go through and calculate out the vertex. So in order to calculate out the vertex, what I'm going to do is I'm going to plug in that 3 wherever I see an x in my original equation. So I had y is equal to, that's difficult to see, y is equal to -x squared plus 6x plus 4. So I'm going to go ahead and put that in. So when I do the negative sign, I want to make sure I put it on the outside of my 3. So wherever the x is, I'm substituting in parenthesis 3 just in place of the x. Anything surrounding the x is going to stay the same. So that negative right there is going to hang tight on the outside. And then I'm going to have plus 6 times 3, and then I'm going to go ahead and I'm going to add 4. So then you can go ahead, if you have a good calculator, you can just punch it in exactly like I have it written here. And you end up getting 13. So then the vertex, the x coordinate comes from the axis of symmetry, which is 3, and the y coordinate comes from what you calculated out, so that's going to be 13. So last but not least, we need to calculate out the y-intercept. Now the y-intercept is always going to be the c value. So since the c value is 4, that means our y-intercept is going to be 4. So let's go ahead and let's take a look at graphing this. So we're going to be kind of jumping around a little bit from the front and the back seat. We're going to kind of write some of the steps out, then we're going to do it on a practice problem. Then we're going to write some more steps out, and then we're going to do it on a practice problem. Now, I do suggest that you actually write the steps down simply because if you're working through a problem and you're thinking, oh, hey, I'm stuck, Miss Humbert's busy, I don't know what to do next, you can just revert back to your steps and figure out which steps you finished and which steps you need to move forward to. So taking a look at graphing quadratics. To find the vertex, your first step is going to be to find the x-coordinate. Now to find the x-coordinate, remember that's that formula opposite of b over 2a, which I think it may have on here. Yeah, just pull it down a little farther, Miss Humbert. So then your step B, or your next step of finding the vertex, is to plug it into the original function to get the y-coordinate. And this is stuff you were all doing on the previous note sheet. So hopefully this is kind of second nature to you at this point. And last but not least, you need to write your answer as an ordered pair. Okay, so that's your kind of steps for doing a vertex. Okay, now let's go ahead right now and let's graph it using a vertex, or at least calculate out the vertex, excuse me. So the first thing we want to do is that x is equal to opposite of b over 2a. Now remember, b is always with the x term, and a is always with the squared term, and c is always our constant, our thing that is just a number. So -6 divided by -2, or 2 times -3, so I end up getting -6 divided by -6, which is 1. So now what I need to do is I need to plug that in so that I can get out what my vertex is. So what I'm going to do is in that quadratic, wherever I see my x, I'm going to type in a 1. Okay, so that right there is what I'm going to type into my calculator. So I'm going to do negative 3 times 1 squared plus 6 times 1 plus 4. So I'm going to put 1 right here. Okay, oops, erase that. So I'm going to put 1 right here. That's the x-coordinate of my vertex. Then I got 7 for the y-coordinate. So notice that I put it in the center of my table. And we're going to talk about why here when we go back to our steps. So let's flip it over and let's go ahead and take a look at step 2, which is making the table. So to make the table, what you're going to do first is you're going to start with the vertex. Now notice that I put that vertex in the center. Okay, so I put that in the center. Then we need to find the other values. So going up, I do 2 values to the left, and going down, I do 2 values to the right. And that's talking about the x-coordinate of the vertex. Once we have those values, we're going to plug them in so that we can get our y. Now that may sound like a whole bunch of mumbo jumbo, but it's something that you've actually been doing a lot so far this unit. So right now, let's go ahead and let's take a look at the table for problem 2. Okay, so what I want to do is I like to go up going this way and go down going this way. Now in reality, it doesn't really matter if you flip-flop that around. The point is that I want to have -1, 0, 1, 2, 3 as my starting x values. So now what I'm going to do is I'm going to plug in 0. So I'm going to go back up to the 1. Wherever I plugged in a 1, now I want to plug in a 0. Okay, and when I plug that in, I end up getting 4. Now here's the cool thing about doing the table this way. If we set it up the way with these x values, then these 2 values on the table will be the same. So this will also be 4. So now we can go ahead and plug in -1. So when I plug in -1, I'm going to make sure when you're squaring a negative number that you're using those parentheses well. So when you plug in a -1, you end up getting -5. Okay, so now let's take a look at step number 3 for graphing this quadratic. For step number 3, you're going to graph the problem. Okay, so we're just going to take and we're going to plot each of those points. Okay, so then what we want to do is go ahead and take a look at problem number 2. Okay, so let's go ahead and graph these points. So for our vertex, we're going over 1, up 7. We're going to plot that point. And then we're going over 0, up 4, left 1, down 5. Then I'm going to go over 2, up 4, over 3, down 5. So now I can go ahead and I can graph this quadratic. Now I notice that my A is a negative value, which means it's opening down. So that means this point right here is going to be a maximum. Okay, so it's something that's really important to remember as we're moving forward, particularly for when we get to word problems. So now what I'd like to do is I would like to go ahead and take a look at number 3. So let's jump to number 3. So biggest thing is, this is what I already just talked about, this is on the front side of your sheet, is that when it opens up, your A is going to be greater than 0. When it opens down, your A is going to be less than 0. And so that's what's going to help us determine. So this one right here is going to have a minimum when your A is greater than 0. When your A is less than 0, it's going to have a maximum. And when we're graphing quadratics, your A is never going to equal 0 because then it wouldn't be a quadratic. Okay, so let's go ahead and let's take a look at number 3. And we're actually going to skip over the last couple steps with graphing the quadratic. I think we're just going to stick to this method. So first thing I need to do is calculate out my vertex. So I'm going to do x is equal to opposite of b over 2 times a. So I get -2 over 2. -2 divided by 2 is -1. So I'm going to plug that in here. So now I need to plug it in so I can get my y-coordinate. So I'm going to take -1 and I'm going to plug it in exactly wherever I see an x. Again, parentheses become really important here, especially when you're squaring a negative number. So I'm going to do -1 squared plus 2 times -1 plus 1. Okay, so now when you plug that into your calculator, and I do suggest that you plug it in along with me so that you make sure you're doing it correctly. When you plug that into your calculator, you end up getting 0. So now we want to go up going this way, so I get 0, 1, and go down going this way. Again, if you flip-flop it, that's okay, but for me, this is just easiest to remember. So now I'm going to take that negative 1 out, and instead of doing negative 1, I'm going to plug in 0. Well, whenever you plug in 0, it's just going to end up being your constant. So that's going to be 1, but also remember that negative 2 is also going to be 1. Now we can do the same thing for 1 or negative 3. It doesn't matter which one you plug in as long as you stick to 1. So since I chose negative 3, notice that I put negative 3 in both spots. Okay, so I get negative 3 squared plus 2 times negative 3 plus 1. Now when I do that, I get 4. So that's going to be the value for both of those. So now we're ready to plot this quadratic. So we're going left 1, up 0, and plotting that point. Left 2, up 1, and plotting that point. Over 0, up 1, and plotting that point. Over 1, up 4, and plotting that point. Left 3, up 4, and plotting that point. So then I have a beautiful parabola. So now I notice that my a is greater than 1, so that makes this vertex right here a minimum. Now it's a minimum because notice the vertex represents the very bottom of the parabola, so that's why it's a minimum. So let's go ahead, we're going to take a look at 4 and 5 here, and we're going to graph those. So every once in a while you may not get a chart. Easy enough, you can create the chart yourself. So we're going to have our x and our y. So the first thing I'm going to do is that is a terrible x. We're going to calculate out the vertex. So we're going to do x is equal to opposite of b over 2 times a. So 2 divided by 2 is going to give me 1. So at the center I'm going to have 1. Now I'm going to take my 1 and I'm going to plug it in wherever I see an x. So I'm going to take those out. And now I'm going to plug that into my calculator. Well, when I do that, I end up getting a negative 9. So I'm going to go larger going this way, and I'm going to go smaller going this way. And now I can start plugging some of those values in. Okay, so now let's go ahead and let's take a look at plugging in some of those values. So I'm going to get rid of that, and I'm going to plug in 0 in its place. Now I like to plug in 0 because when I do that, I can just take the constant. So then each of these are going to be negative 8. Remember, we want to make it reflect. Okay, so then last but not least, we're going to take the 0, and we're going to plug in the 3. So then, now, when we do that, you take that and you plug your calculator into that, and you end up getting negative 5. Okay. So now, what we want to do is we are going to plug that into the graph, and we're going to actually graph those points. So we're going to do 1, negative 9. So that's going to drop down to here. Now we're going to do that dotted line, and then we're going to go 2, negative 8. And we're also going to do 0, negative 8. Now that dotted line I just drew, it can help you maintain symmetry. We talked about axis of symmetry, so it should be symmetrical on either side of that dotted line. And then we're also going to do negative 1, 5, and 3, negative 5. So now I have a parabola that is bright and ready to be graphed. So that is my final answer. Notice that a is greater than 0. So again, the vertex is a minimum. That eye looks funny. Okay, let's take a look at this last problem here for this note video. So what you'll notice is we just have a negative 3x squared. So that tells me that my b is equal to 0 because there's no x term, and my c is equal to 0 because there are no constants. So let's go ahead and let's take a look at graphing this out. So I'm going to make my chart. So I'm going to do x is equal to opposite of b over 2 times a. Well, 0 divided by anything is going to be 0. So I'm going to plug that in here. We're going to get bigger going this way and get smaller going this way. So I'm going to plug in each of those values for x. So I get negative 3 times 0 squared. Well, that's just going to be 0. Negative 3 times 1 squared, that's going to be negative 3. negative 3 times 2 squared, well, that's going to be negative 12. Well, negative 12 is clearly off our graph, so all we can do is graph these points, the first three. So we're going to point out that point at 0, 0. Then we're going to go over 1, down 3, which is right here, left 1, down 3, which is right here. And now I can go ahead and draw in my parabola. So again, since the A is less than 0, my vertex is a maximum. And now notice that the vertex is the maximum of the parabola. It doesn't get any higher. Okay? So then, that concludes your note video for this part. You can go ahead and watch the second part once you're done. Okay? So I would suggest trying graphing a couple on your practice sheet and then going ahead and doing the word problems once you've had some practice. Okay? Thanks for listening.